Okay, I'm just going to let you know I'm trying to write on this thing for the first time, so my handwriting is definitely going to be sloppy. You're forewarned. Okay, number 4. If you threw a ball up in the air at a velocity of 1200 centimeters per second, part A asks, what will its velocity be at the highest point? We could answer that right now. It takes no calculations at all, just a little bit of thinking. However, let's look at what they gave us first. They told us that we're throwing it with this speed of 1200 centimeters per second. Now, we have a problem already. We don't like centimeters. We like to use meters when we do these calculations, so we need to convert that very first thing. What you need to remember to do that, you should probably kind of know by now, is there are 100 centimeters in 1 meter. That's an M. Okay, so what we have to do to convert that to meters per second is we take 1200 and simply divide it by 100. That's basically moving the decimal place 2 to the left, so that gives us an answer of 12 meters, that's an M as well, per second. Okay. That's the speed that we're starting to throw this ball with, so I'm going to label that VI. Our initial velocity in this problem is 12 meters per second. We're no longer using the 1200. Part A, they ask you, what will its velocity be at the highest point? So if we're just talking about as this ball goes upward, they're asking for the velocity final. Velocity final. What will that equal? Well, if it's thrown at the speed of 12, as it goes up in the air, gravity is going to slow it down. So it goes up, 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 it's slowing down more and more and more. When it gets to the very top, it's slowed all the way down. If it's slowed all the way down, you should know what speed it is. It's reached a speed of 0 at the very top. So make sure you have a label for that, meters per second. Okay, so thinking about the way up, we know VI is 12. At the top, VF is 0. Now they ask you how much time will it take to get to the highest point. They're asking for what is delta T. Now there's one more piece of information that we know and we haven't listed yet. All these problems were on Earth. So we know the acceleration of gravity, g, is going to be equal to that negative 9.8 we always talk about. Meters per second squared. Okay, so knowing time is what we have to find. We're given velocity final, velocity initial, and the gravity. We can solve for delta t. We have to pick the right motion equation to do that. So far in this problem, we've not written down anything about height. Since our problem has nothing to do with height yet, we choose to use equation number 1. So equation number 1 is velocity final is equal to velocity initial plus acceleration times time. Okay, well, we know velocity final is 0. Let's go ahead and plug these in. I think a lot of you like to plug in the numbers first. So velocity final, I'm plugging in 0 for that. That's what it says here. Is equal to velocity initial is 12 plus our acceleration is a negative 9.8. Put that in parentheses. Negative 9.8 multiplied by our time, which is what we're trying to solve, so just delta t. Okay, we have to get delta t by itself. The first step in doing that is getting rid of this 12. Right now, this is 12 plus this side of the equation. We're adding 12 to whatever this side is. So the opposite of adding is subtracting. what we're going to do is subtract 12 from both sides of this equation. When we do that, subtracting 12 from this, that'll go away. What's left over here is negative 12, because we subtracted it, is equal to negative 9.8 multiplied by that delta t. Okay, our last step is just to get rid of that negative 9.8. So what we're doing is we're taking a negative 12, we're going to divide 9.8 on each side. Sorry, it should be negative 9.8. Because that gets rid of it over here. So now our 9.8s go away over here. We're left with negative 12 divided by negative 9.8. So our time for this problem, delta t, will equal 12 divided by 9.8. Now when I do that in the calculator, I'm not even going to include the negatives, because a negative divided by a negative, I know will give me a positive. So when I plug it into the calculator, 12 divided by 9.8 gives me my answer of 1.224489, yada yada. Just round that to 2 digits after the decimal. So for this answer, 1.22 is good enough. 1.22, that's a 2. This is a time, and we measure time in seconds. Alright, there's my answer for part B, 1.22 seconds. C asks us how high is the highest point. So now we can use the fact that we know the time and try to find out what is this delta y going to be. How high did the ball get? Okay, once again we have to pick the right equation to do that. Hopefully you have a little bit more room than I do. I'm going to have to erase some of this. So know that we found our time up here was 1.22. Try to make some room here. Write that again to remind you. Delta t is equal to 1.22. Okay. We have to find delta y now. If you look at your equations over here, we do know velocity final. It's 0. If you want to find delta y, I think it'll still be easiest to use equation number 2, just because delta y is already equal to something. So using equation number 2, delta y is equal to velocity initial, which we know is 12, so 12 times time, which is 1.22, plus 1/2 our acceleration. We know that's the negative 9.8, so multiplied times negative 9.8 times the time squared. So our time is still the 1.22. We just have to square that value. Alright, so now it's just math. We have to solve both of these sides. So let's solve this left side of the equation first. 12 times 1.22. So in the calculator here, I'm going to clear this out. 12 times 1.22 gives us 14.64. Plus this half of the equation. Now when you look at this, you should know that we have to square that 1.22 first. So let's go ahead and do that. In your calculator, what that means is we're multiplying it by itself. So 1.22 times 1.22 gives us this. So that's what 1.22 squared is equal to. We then have to multiply it by 1/2 and negative 9.8. So times 0.5 for 1/2. Let's try that again. 1.4884 times, maybe in this calculator, 0.5 is equal to, okay, times, still have that negative 9.8. So I'm going to write times 9.8. I have a bad calculator here. You can add the negative to it if you want to. Oh, man. Okay, let's try this again. 0.7442 times 9.8 gives us, thank you. No, that should be negative since we're dealing with that negative 9.8. So this was minus 7.29316. That'll be good enough. Your final answer is adding those two together. So we have a positive 14.64 and a negative 7.293. So in the calculator, the way I'll write that is 14.64 minus, because I'm adding a negative, 7.293. That gives me an answer of the height of my ball. I'll put it in red for you. So delta y is equal to 7.347. Oops. I'm going to write just 7.35. Meters is our measurement. Okay. Now, good news is there's no calculations left. If we just think about these other last two questions, we can come up with our answer. Part D says, how much time does the ball take to come down from that highest point? Now, here's the deal. Gravity affects it on the way up the same way it affects it on the way down. On the way up, it took the ball 1.22 seconds to get to the top. Therefore, on the way down, it's going to take that same amount of time to come down. There's no calculations to do. We already know our answer. The time for the way down is still that 1.22 seconds. Part E asks us, what is the ball's velocity when it gets back to your hand? So we threw this object upward at a speed of 12. It got all the way to a stop at the very top of its trajectory at a speed of 0. Then it came down. When it got back to where it started, it should have reached that same speed. So the speed that we threw it up in the air is the same speed it has when it's on its way back down. So the velocity on the way down is still that 12 meters per second. Now the only difference is now it's on its way down, not its way up. So what we have to add to that answer is a negative sign to show the direction downward. Okay, I know that it was a lot. I know that it was sloppy, but hopefully that helps you with number 4. Number 5 is the exact same problem, it's just we have a different velocity for our object. So use this number 4 to complete number 5.